welcome to Cherry Pie Math. This video is going to introduce rational versus irrational numbers. So some things to kind of know before we get started is about like fractions versus decimals, like how they're similar, how they're different, and also what makes a number whole. So if I say a whole number, you should be able to know what a whole number is. So first off, I want you to look at this. You've hopefully seen this before, and this is a number line. We can use it to plot numbers. So I want you to pause the video and try to figure out where each of those numbers would go on this number line. Okay, so everyone's would look a little bit different, especially because I haven't labeled this number line, but let's just pretend this is 0 over here. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then going this way would be -1, -2, -3, -4, -5. I would recommend usually, like, if you're doing this, I would put 0 in the middle, especially if you have positive and negative numbers, just so you can have a view of both sides. Okay, so some of these would be easy. Like, for example, 4 would obviously go right here on the 4 spot. -2. 7.5 would be in between 7 and 8. Remember, 0.5 is like halfway. So 7.5 would go right here. -1/2, that wouldn't be all the way to -1, it would be halfway to -1, so it would be right here. Another way to think about it is -0.5. And then we have -7/3. There's a few ways to think about this. You might think, oh, that kind of similar to -1/2. We want to see how many times we're going to move to the left. 3 goes into 7 twice, and then we'll have an extra 1/3. I guess, and that's negative, so it would be -2 and 1/3, so it would be kind of like here, next to that monster -2. Another way to think about it is to change it into a decimal. You can do that on a calculator, or you can do that by hand, but you would kind of get -2.33333 forever, and it would end up being in about the same spot. So the number line kind of helps us keep track of where everything goes, where everything is in comparison to each other, especially when it's in decimal form compared to fraction form. As we go forward, we're going to be talking about rational versus irrational. So it helps to think about what rational means, like in the English language, because in math, we often will use words that are slightly different than the way you would use it in regular English. So the English definition of rational is something reasonable. Something reasonable. I guess like logic. And you could look this up. Like if I went to Merriam-Webster or whatever dictionary you want to use, right? It would have like a much more rational definition of rational. See what I did there? But it basically, at the end of the day, rational just kind of means like level-headed, logical, very reasonable, something that makes sense. The mathy definition of rational kind of goes along with that in that it makes sense to us. It's the kind of numbers that we're familiar with. But to really understand what rational means in math, we have to go back to what we call the natural numbers or the counting numbers. So natural numbers are, and I'm going to come up with the definitions first, and then I'm going to sort them into the different categories. So natural numbers are numbers you count. Like 1, 2, 3, etc. So it's the kind of numbers that you start when you're in like kindergarten, or like even before kindergarten, when you're like 2 and you're starting to learn how to count things. You don't start with 0. If someone asks you to count, you don't, like for hide and seek, you don't say 0, 1, 2, 3. You start with 1. Natural numbers start with 1, and they're the whole numbers that go all the way to infinity. So natural numbers in this case would be like 5, and 10. And 1,320. Those are all natural numbers because they're all bigger than 1 and they're all whole numbers. Whole numbers are very similar to natural numbers, but it's natural numbers plus 0. So in addition to the 5, the 10, and the 1,320, we would also have the 0. So I'm just kind of adding on to that. Integers are like whole numbers, but it includes the negative numbers. So it would be like whole numbers plus negative counterparts. So it's really anything that's not a fraction or a decimal in the way that we think about it. So I have the 5, I have the 10, I have the 1,320. I have the 0. But integers would also be like -3 would be an integer, or -487 would be an integer as well, because they don't have any extra decimals. There's no like missing parts to this. Rational numbers is a step above that. So we've kind of been adding on to it. We had the natural numbers, and then we had the whole numbers where we added 0. Then we had the integers where we added the negative numbers. The rational numbers is anything you can represent as a fraction. So I'm gonna write anything you can represent as a fraction. And the official, like, if you were going to get all technical about it, you would say like P over Q, or P and Q are elements of the integers. Like, that's how you would often see it, especially in like fancy math classes. But for now, we're just going to say anything that you can represent as a fraction. And that includes decimals. And we're going to get a little bit more technical with the decimals here in a second. But this would be, so 5 is something you can technically, any whole number you can really represent as a fraction, because it's just 5 over 1, for example. Or 10, or 13, 20. 0 is technically something you can represent as a fraction, because you can do 0 over literally any number except for 0. Then we have the integers -3, -487. Let me change the color here, change it to green. But then we also have -3.2, and we have 3/2. Those are all things that can be represented as fractions as well. Even the -3.2, even though it's a decimal, that one can be converted back into a fraction. We'll talk about that later. But that's basically what a rational is. A rational is anything you can represent as a fraction. If you remember nothing else from this video, remember that rationals is anything you can represent as a fraction. So, what do you notice every time we go up a step or a category? You probably noticed that we were just adding on. So every time we go up a category, every time we added more to the definition. Another way to say that is we keep everything from before. So like whole numbers include all the natural numbers. All natural numbers are also whole numbers. And all natural numbers are also rational numbers, because they fit into both categories. But it doesn't work the same other way. Like -487 is not a natural number because it isn't positive, it isn't after 0. So anything here kind of fits in there, but it doesn't necessarily work the other way. So there's a couple of different categories. We have the natural numbers, which we just talked about, and we have the whole numbers, and we have the integers, and we have the rational numbers, and that's kind of where we've been to so far. Rational numbers, anything that can be represented as a fraction, is under the umbrella of what we call real numbers, which is anything you can represent on a number line. And then those are under the umbrella of what we call complex numbers, which aren't actually that complex, but we call them complex because they ran out of words. And I'm not going to go over that in this video because really all we care about is rational, but it's kind of nice to see the general picture and that each of these fits under the umbrella of the next item. I do want to talk about real versus rational. Just kidding. We're going to talk about that in a second. Okay, so let's find some integers. Sometimes the integers are hiding. When I say hiding, I mean that they aren't always just like 15, for example. So this is actually an integer because even though there's a decimal places, everything after the decimal point is a 0. When it's a 0 after the decimal place, we don't actually write it. It means that there's no leftovers anymore. And so this would be considered an integer. Even though I wrote down 0.000, it's still an integer because we can just ignore it. Kind of same thing with this, -3/1, also an integer because anything over 1 is just whatever is on the top. -3 is an integer. This is an integer. This is an integer. This is not an integer because I have something in the decimal place. This is also not an integer because it's a fraction, but this is an integer. Even though it's super big, there's no leftovers. There's nothing in the decimal place. There's no fractions associated with it, like leftover fractions. So it would be an integer. So just be careful about that. Sometimes you'll see, like, I know when I'm going to make a test for this, that I'm going to put down some numbers that are like, that you would think are going to be decimals, but they're not. Actually, they're integers. So kind of relating to that, a 0 in the decimal place means that there are no more leftovers. So that there's no, like, because when you're dividing, sometimes you have a remainder. I guess that's another way we could say that. There are no more remainders. So like if I did 5 divided by 3, for example, 3 goes into 5 one time, but I still have a remainder of 2. That's not going to be an integer, or it's not going to have a decimal of 0 because I have that leftover. But if I did 15 divided by 3, 3 goes into 15 exactly 5 times. There's no leftovers, and that would make the decimal places all 0 because there's nothing left. And that would be an integer. So let's kind of review how to convert things to a decimal, because this will be pretty key, especially with the coming videos that I'm going to make. You should be able to convert it to a decimal, even if you just use a calculator, but it is helpful to know how to do it by hand as well. So to convert fractions to decimals, you just divide the top by the bottom. So for example, 5 divided by 8, 8 goes into 5 0 times. And so because of that, I put a 0 on the top, and now I'm going to put in an extra 0 because I'm not actually changing the value. There are technically an infinite amount of zeros, I guess you could say, after every single number in the decimal place. We can use them if they fit our needs. So for example, 8 goes into 50 6 times. So that 6 times 8 is 48. Subtract that, I end up with 2 as a remainder. And so I'm going to add another 0. 8 goes into 20 twice. Left over 4, I do it again. 8 goes into 40 exactly 5 times. And I'm left with a remainder of 0. That means this is the end of my fraction, or my decimal. So this would be 0.65. And if you were to do that in a calculator, you would have ended up with exactly the same thing. 2 divided by 7 is going to be a little bit trickier. So I'm going to make a really long thing here. And it's the same idea, though. We start out with putting the 2 on the inside, the 7 on the outside. 7 goes into 2 no times because it doesn't fit. So I have to add in another 0. Sorry, I don't want to put the 0 on the top. I want to put the 0 down here. So 7 goes into 20 twice. So I'm going to subtract that. I end up with 6. Pull down the 0. 7 goes into 60. What is that? 8 times. That would be 4. Do it again. And you really just keep going. Calculator is a lot faster, but a lot of tests will require you to be able to do this by hand. That goes in 5 times. So that's why I said you should probably know how to change fractions into decimals before this video, because if you don't remember, then this video probably doesn't make a whole lot of sense of what I'm doing. Well, I'm running out of space. So I just keep going. Just kind of go sideways, I guess. 7 goes into 30. What is that? 4 times. End up with 2. That becomes 20, and then that goes in twice, so I have 14, and I end up with 6. And you can kind of see, I forgot to put the 2 up there, that I'm starting to repeat. I have this 20 like I did up here. I have this 14. Now I have a 6 like I did here. I'm repeating the same process, and so I'm going to end up with actually exactly the same pattern that I already had if I kept on going. And it would just keep going on forever because I wouldn't be able to stop. When this happens, what we do is we write down all of the things that repeat. So 2, 8, 5, 7, 1, 4. And then it started repeating at the 2 again. So I put a bar on top of it to show that I'm just going to copy and paste this over and over. So when you're calculating a decimal from a fraction and you notice that it starts to repeat, that's what you can do. Instead of writing it a bajillion times, you can just write down what does repeat and then put a bar on top to indicate that it's going to be repeating. Okay, so those are both rational numbers because they were able to be represented as fractions. So if you're looking at a decimal and you're not sure if that decimal is a rational number, you can check if all the decimals are zeros. So like 15.000, that would be a rational number because we just ignore the zeros. A decimal that ends kind of similar to that, it just means that there's no more leftovers. We've covered all of our bases. There's nothing left to worry about. Or a decimal that repeats. So like that'll happen, especially with lower numbers, if it's over 3, over 6, or over 7, or over 9. Those are the big ones where you're going to see that it repeats. So what if that doesn't happen? What is an irrational number? An irrational number is the opposite of a rational number. It is a number that cannot be represented by a fraction but can go on a number line. That's a big key, because remember I talked about real numbers and that was anything on a number line. So an irrational number is a number that can't be a fraction but can go on a number line. So it basically means that the decimal is going to repeat forever. If you have a decimal that repeats forever ignore what I just said. If you have a number that does not repeat, then that would be an irrational number. So for example, pi. Pi is one of the biggest known irrational numbers. It goes on for infinity. It's 3.1415. That's the ones we all know, right? But then it keeps on going and it just doesn't stop and it doesn't repeat. So there is no fraction that can be pi, but you can still find pi on a number line. Other examples is a square root of 2. That's another very common irrational number that you'll see, and we'll actually see that in some later videos. E is another example of an irrational number. This is something you don't really see until high school, but it's a number. All of these are just little symbols because we can't write down the entire decimal. They don't repeat and it goes on forever. So that is an irrational number. An irrational number is a number that cannot be a fraction but can go on a number line. So from this video, things to remember: decimals need to have zeros and or repeat in order to be a rational number. If it doesn't fulfill those qualifications as a decimal, like it doesn't repeat and it goes on forever, then it's an irrational number. Numbers have different umbrellas. So like natural numbers are under the umbrella of the whole numbers, which are under the umbrella of integers. I don't know why they choose to make that a z, but it is. And then it's under the umbrella of rational numbers, which is under the umbrella of real numbers. And it just keeps on going. Converting a fraction to a decimal can help you determine if it's irrational. Converting a fraction to a decimal can help determine if it's rational. I can't talk. And it can help you find it on a number line, especially if you have like these crazy fractions with like thousands of numbers. Changing it to a decimal helps you kind of figure out where it would go on a number line. Anyway, I hope that helps. I'm excited to teach about irrational numbers, and good luck.